time I'm going to do this using the long drawn-out formulas with the dimensional analysis. Let's first look at the copper sulfate. I started with 10.0 grams of CuSO4. For every 159.61 grams, 1 grams, I have 1 mole of CuSO4. Now I have my stoichiometric step, and for every 3 moles of CuSO4, I would use 1 mole of Cu3PO4, 2. This is my stoichiometric conversion step. And now, for every mole of Cu3PO4, 2 weighs 380.58 grams per mole of Cu3PO4, 2. And when I take this number and divide by this, I come up with this number. When I divide by 3, I come up with this number. And when I multiply by 380, I come up with this number. So the value is 7.95 grams of Cu3PO4, 2. Now, if I looked at the other chemical species, which was the excess reagent, I started off with 0.5 liters of a solution, and that solution had 0.1 mole of Na3PO4 per liter. And that gives me the number of moles, 0.05. And now I do my stoichiometric step, 2 moles of this to 1 mole of this. So I have 2 moles of Na3PO4 for every 1 mole of Cu3PO4, 2. And let me put this all into one parenthesis here. And then the copper weight, the molar mass of this is 380.58 grams of Cu3PO4, 2 per mole. And if I had multiplied this out, 0.5 times 0.1 is 0.05, divided by 2 is 0.025, multiplying by its molar mass would be 9.51 grams of Cu3PO4, 2. Now, obviously, we run out of this reagent first, and so we can only make 7.95 grams because we've run out of the copper sulfate and we have excess sodium phosphate. But notice that in red, everything is what I did up here. I calculated the moles and divided by the coefficients. And then I multiplied whatever those numbers were by 1, and then I multiplied them by 380. So I did not have to do this work in order to calculate the answer. At this step, you have the limiting reagent. So to review what we did a minute ago, if you calculate the moles of this and you calculate the moles of this, you divide by the coefficient and you divide by the coefficient. Whichever is the smallest number is your limiting reagent. You then multiply by the coefficient of the species you want, and then if you're solving for the mass, you then multiply by the molar mass. So both of these came up with the same answer. There's nothing wrong with doing it this way if that's easier for you, but this way could be quicker. Thank you.